Today, we will answer a geometry challenge coming from one of our followers. And the question goes like this. Let's start with a semicircle. Now let's draw a square like this, with a side length of 1 unit. Now let's extend one side of the square, and let's draw a chord like this. The measure of this segment simply equal to 1 unit, and let's call this angle be equal to theta. Now the question is, what is the value of tangent of theta? Pause this video right now and see if you can answer this question, because I will show you the answer and the solutions in 3, 2, 1. Alright, the answer simply equal to 5, wherein phi equals 1 plus square root of 5 over 2, and that is the answer to this question. In this video, I will show you 3 different approaches to answer this question. So the first one is using congruent triangles. The second one is using Pythagorean theorem. And the third one is think outside the semicircle. Let's begin with our first solution using congruent triangles. In order to solve this question using congruent triangles, let's name some important points. So let's name the center of this semicircle as O, this is A, this is B, this is point C, this is point D, and this is point E. Now, let's draw radius OA and OB like this. And let's call this as R. Let's connect point A and point B. Now, take note, this triangle AOB is an isosceles triangle because two sides are equal. Also, take note that triangle AEB is an isosceles right triangle because this angle AEB is a right angle. From here, let's connect point E and point O. From here, take note that OA simply equal to OB because they are both equal to radius. And AE equals to side BE, they are both equal to 1. And EO simply equal to EO by reflexive property. In short, using SSS postulate, we can say that triangle OAE is congruent to triangle OBE. Using the fact that triangle OAE and triangle OBE are congruent, we can say that angle OAE is congruent to angle OBE. And since side BE and side CO are parallel to each other, we can say that angle BOC is also congruent to angle OBE because they are both alternate interior angles. Now recall, OA simply equal to OB because they are both radius of our semicircle. In short, by hypotenuse angle congruence or HAC, we can say that triangle ODA is congruent to triangle BCO. So we have ODA and BCO. Since we now know that triangle ODA is congruent to triangle BCO, we can say that AD simply equal to OC because congruent parts of congruent triangles are congruent. We know AD, this is just AE plus ED. And AE, we know this is 1. And ED is also 1 because this is just the side of our square. So OC is just 1 plus 1 or simply equal to 2. Since we now know that the length of this segment OC is 2, we can now focus to this triangle BCO. Now, what is the length of this side length BC? This is just 1 because this is just the side length of our square. We have a right triangle BCO. We can now use the Pythagorean theorem to find the value of R, or the length of our radius. We have R squared equals 1 squared plus 2 squared. Solve for the value of R, and we get that R simply equal to square root of 5. We now know that the length of the radius of this semicircle is square root of 5. We need the length of this DO. So what is the length of this DO? We know OC is 2 and CD is 1. In short, this DO simply also equal to 1. Using this information, we can now get the value of this tangent theta. We know DO is 1, this radius is square root of 5, and this AD simply equal to 2. So using the definition of tangent function, we have tangent theta equals the opposite side over the adjacent side. The opposite side simply equal to 1 plus square root of 5, and the adjacent side is just 1 plus 1, or simply equal to 2. In short, tangent theta simply equal to 1 plus square root of 5 all over 2, or simply equal to phi. And that's our solution using congruent triangles, a lot of congruent triangles. So let's begin with the second solution, the Pythagorean theorem. Suppose we don't know the length of this segment DO. So let's call this as x. On our figure, we know this BC is simply equal to 1, and this CD simply also equal to 1 because it's just a side length of the square. Also, ED is 1. Since we have two right triangles, we can now use Pythagorean theorem on triangle ODA. So using triangle ODA, we have r squared equals 2 squared plus x squared. Now, how about on triangle BCO? Using Pythagorean theorem again, we have r squared equals 1 squared plus 1 plus x raised to the power of 2. Since they are both equal to r squared, meaning the two expressions are also the same. Now solve for the value of x, simplify, combine like terms, and sure enough, we get that x equals 1. So the length of this DO, or this x, simply equal to 1. And using the value of x, we can now solve for the value of this r, the radius of our semicircle. So let's replace this x with 1. Solve for r. We have r equals square root of 5 again. And using those information, we can now get again the value of this tangent theta. So we have opposite over adjacent, and this is just 1 plus square root of 5 all over 2. And that is our answer using the Pythagorean theorem. Now, let's begin with the third solution using think outside our semicircle. And let's begin. To solve this, using think outside the semicircle, let's focus on our semicircle. Since we have here a square, this side length right over here is also equal to 1 unit. And the vertical height simply equal to 2 units because 1 plus 1 is 2. On this moment, we don't need this square anymore. Now, from here, let's connect this point of intersection to our endpoint of our diameter like this. And let's call this angle be equal to alpha. Now, since we have a triangle inside our semicircle, and the hypotenuse, or the longest side, is our diameter, we can say that alpha plus theta simply equal to 90 degrees. Or simply, this is just a right triangle. Since this is theta, and we know alpha plus theta is 90 degrees, this angle right over here is also equal to alpha, and this angle right over here is also equal to theta. Let's focus on this right triangle right over here. We know this is just a right triangle from the start. Using the definition of tangent theta, we have the opposite side over the adjacent side. We know the adjacent side of this right triangle, this is just 2. In short, the opposite side simply equal to 2 times tangent of theta, or this side right over here on the bottom part. This is just 2 times tangent of theta. Let's focus on this small right triangle. Using again the definition of tangent, opposite over the adjacent, the opposite side of this angle theta is 2, and the adjacent is just the adjacent side. We don't know the adjacent side, but we can get the adjacent side. This is just 2 over tangent of theta. So this is just the adjacent side of our theta. From here, let's create a rectangle like this. What we know about this rectangle? The length of this side simply equal to 2 times tangent of theta, for sure. Since the name of our solution is think outside the semicircle, so let's extend this segment like this, such that if we connect this point of intersection to this point, this angle right over here is also equal to alpha. And then let's create a rectangle outside of our semicircle like this. We know that alpha plus theta adds up to 90 degrees. If this is alpha, this angle right over here simply equal to theta. This is alpha, this is theta, and this angle simply equal to alpha. Focus on this segment 2 over tangent of theta. By symmetry of our figure, this segment right over here is also equal to 2 over tangent of theta. And take note, this figure on the bottom right corner simply a square. In short, all of its sides simply equal to 2 over tangent of theta. Now, since this is a rectangle, this segment right over here simply equal to 2 over tangent of theta. Now, let's focus on these two right triangles. What we know about these two right triangles? Their acute angles are alpha and theta, and they have the same hypotenuse. In short, they are congruent. So, this side length 2 times tangent theta is the same thing as this side, which is equal to 2 plus 2 over tangent of theta. Since they are the same, we can equate these two sides. Divide both sides by 2, multiply both sides by tangent theta, and equate this to 0. And sure enough, we have tangent squared theta minus tangent theta minus 1 equals 0. If we use quadratic formula to find the value of tangent theta, we get that tangent theta simply equal to phi, or simply 1 plus square root of 5 all over 2. And that is our answer to this question. Therefore, using three different methods, using congruent triangles, Pythagorean theorem, and think outside the semicircle, we get the same result that says that tangent theta simply equal to 1 plus square root of 5 all over 2. And as always, we are done.